Hello and welcome back to another video in the game development series. In this video we'll continue working with the geometry cylinder which we started implementing in the previous video. So we left off by being able to render a cylinder on the screen. However, we noticed that the cylinder itself has faceted edges. So in other words, the edges or the sides of the cylinder look very sharp. In this video, I'm going to show you how we can smooth out the look of the cylinder so that even if it has a low number of sides, the cylinder itself still looks relatively smooth. So how do we do this? Let's go into PaintShop Pro and first of all describe what the problem is. Why is it that the object itself is looking faceted on the screen? I can go in here and create a simple geometry to work with. So let's see here. I wonder if we have a simple shape here. Okay, let's say we made a cylinder that's made up of 8 sides like this figure here. In our game engine, what we'd have is the following cross-sectional view. And each of the vertices would be represented using these points here. So we'd have 8 points. And let me just label these. And as you remember, we have a center point here, and the line that connects from the center point to any of these vertices is defined by R. And also, in the previous video, I described how these points are generated, how they're oriented, and all that. So I'm not going to go over that again this time. So what we want to describe here is why is it that the cylinder itself looks faceted. We've calculated in the constructor the normals for each of these faces. So what I'm going to do here is just draw out the normals that we're using. For this 8-sided figure, we'll have 8 normals, and my drawing here isn't all too accurate, but I hope you get the general idea of what's going on. So each of these red lines here represents a normal, and each of them should be exactly perpendicular to the side of the face that it's associated with. Now when we go and render each of these sides, what we're doing is we're specifying use this specific normal for the specific vertices that make up that face. So for instance, when we're rendering this face here, let's pick blue here, for this vertex we specify use the normal that's specified here, use this normal specified here. Then we go to render the next face. Well, when we're using this one, for this vertex, we're using this normal, and here we're using this normal. So notice this normal is applied to both, or actually 4 vertices for each face, because we have 4 vertices defining each face. Now we can go ahead here and draw all the normals that we're actually using. Well, when we do this, you can now begin to see why it is that the cylinder itself is looking faceted. At the corners, let me just finish just drawing these normals here. At the corners, pick any corner, it doesn't matter, you'll notice there's actually 2 normals. There's the normal that's defined by this face, and there's the normal that's defined by this face. So at the corner, we have 2 normals, and because these 2 normals are not the same value, or in other words, they're not pointing in the same direction, what we get is a very sharp-looking edge. To fix this, or in other words, to smooth it out, what we want to do is calculate the average between these 2 normals. So it's going to be somewhere in between. This average normal is the one we want to apply, and if we do that, then the resulting cylinder will have a very smooth looking face. The sides of the cylinder are still going to be flat, but the shading that OpenGL will apply will look relatively smooth because the normal itself is an approximation of the normal of this one plus the approximation of the normal of this one. So our goal in this video is to go into the constructor and modify it so that instead of having to use these blue normals, which is what we're using right now, we can go and use these orange ones here, which I've labeled now in the diagram. So that's what we're going to do. let's go into C++ here, and let's see what we have open here. We have the geometry cylinder. Now, to make the changes, we're going to have to introduce a new variable. And the variable itself is going to be a Boolean. And the Boolean will define down here inside of the private members. So I've labeled it m_b_smooth. So if this is true, we want to smooth the surface of the cylinder. If this is false, we'll just do exactly the same thing that we did in the previous video. We won't touch anything, and we'll use the blue normals. If we pass in true, then we're going to instead use the orange normals, which I drew just a second ago. Now this new variable we're going to pass into our constructor, be smooth, and when we do that, we need to go inside of our CPP and also make the addition here. Now one thing I'm going to do is I'm going to make this default to true. So if you don't specify this fourth parameter, it'll automatically use the smoothing technique. And most of the cases you will want to smooth your cylinders just because they look nicer. Under certain conditions you may not want to smooth them, so you will want to go in here and specify false for this last parameter. Okay, so in here we're going to take that mbSmooth variable and just set it to whatever the user specifies inside the constructor. And we don't have to make any changes here. We'll still have to allocate memory, do all the calculations, do all the normal calculations, and then down here we have to do some additional work. Okay, so let's take a look at what we're going to be doing. If we're using the smooth operation, then we're going to go inside of the statement here. If we're not using smoothing, we'll just skip over this section and not worry about it. So the first thing we do is we create a temporary pointer to a vector 3, and this temporary pointer is going to be used to hold the resulting normal that we're going to calculate. And again, the resulting normal is this orange value here that we're going to calculate for each section that we need to use. So we called a new operator, and the number of these new normals we're going to need is going to be equal to the number of sides. Before, when we used the normals, we had a normal defined for every face. So you notice that I drew it in the center of each of the sides. Well, now we're going to be calculating normals, but the normals are going to represent the edges. So that's why I drew them at the location of the vertices. There's still the same number of red normals as there are orange ones. We've just sort of moved them from the center of the face to the edge location. Keep that in mind when you're looking at the code. So we called a new operator to give us the number of normals we need equivalent to the number of sides that we're going to be creating. If this returns OK, meaning it's not null, we can then go and calculate the average of all the normals along that vertex where the two blue normals are meeting. To do this, we create a for loop and we go through all the normals from 0 to the number of sides. Now remember, up here up above, here, we did already calculate the normals for every face. And these are what we're going to be using down below here for the averaging technique. So what we're doing is, if we start off with normal 0, then we're going to take the normal value, which was calculated up above, from the previous one. So this is number of sides minus 1. And we're going to save that inside of our temporary member variable here. Otherwise, if we're not starting at 0, then we just take whatever value of n we're currently at, and we're taking that guy's previous one. And we save that inside this temporary variable here, which we're going to be using to store the normals. Once we have that value, we add it to the value of the normal located at n. So notice we're taking n minus 1 and adding it to n. However, there's a little bit of a if statement here that we have to take care of, and that's whenever we're working with n equals 0. Because n equals 0, if we went into here, we would then be looking at the normal located at minus 1, but that one doesn't exist. So because of that, we have to go to the very end where it wraps around and use the previous one, which is actually I number of sides minus 1. Again, if we go back into here, let me show you what I mean by all of this. If we go into this guy, it's the easiest way to do this. Let's just go and rotate this whole image so that it is more in line with what we have in our code. Okay, if this is the image that we have of a cylinder that we're going to be creating, let me label some points on here for you. This one here is going to be, well, actually I should be labeling the red ones. This is going to be N0, N1, N2, N3, N4, N5, N6, and this is N7. So we're going to start off with calculating the average of N0. So N0, we're going to take N, over here I'll also write number of sides for this case is equal to 8. So we start off at N is equal to 0. When we have N equal to 0, we take the previous guy, which is number of sides minus 1, so this is 7, and we average this one with N0. So we take this guy, and we average it to get the resulting orange guy here. Then we skip over to N equals 1, which is this guy here. There we take the previous one, which is N0, and average it with N1. So we're taking this guy and averaging with this guy to get this guy, and so on. And when we work our way all the way around, calculating all of these orange normal values. So here we go again, from N equals 0 all the way to I number of sides, and we're just taking the previous one, adding it to the current one, and then once we have it, we go and normalize it, and that gives us the average or the resulting orange normal that we see in that diagram. Once we have all of these normals, we then need to save them back into our member variable, which holds all of our normals. Because right now, what we did is we created this memory up here to hold all the normal values. So all we do is go back through the for loop one last time, and this time we're just copying all the values that are stored in this memory and putting it into our member variable memory. And at the last thing down here, we just go and clean up the memory that we allocated for this normal. Since we no longer need it, everything that we did and calculated up here is now saved inside of our own member variable. So that's what the constructor will now do. So this will give us the new normals. However, inside of render OpenGL, we now need to make some decisions based on when we want to use a specific normal for the edges, or when do we want to use a specific normal for the faces. So here's how we implement this. First thing we need to do is preserve this normal function call here, so that if we're not using smoothing, we can still use this normal values that we specified here. And to do that, all we need to do is call if not be smooth. And by doing that, then what we're going to do is use the existing method of using the normals. We don't have to change anything down here for the top cap and the bottom cap, because both of these don't get averaged. We're using the exact same values for the normals, whether they're smooth or not smooth. So we leave these the same. The only difference is up here for the column section of the cylinder itself. If we are not smoothing, we're going to use this technique for using the normals. If we are smoothing, we do something different. Now, the something different that we're going to do has to go inside of these if statements. When we call GL normal 3F out here, this normal value gets applied to all 4 vertices that are listed down below. However, when we're using the edge normals, we need to specify 2 normals per face rather than 1 the way we're doing it here. So going back into PaintShop Pro, in our OpenGL render call, we have a for loop that's going from face to face to face to face. However, when we're rendering using the smooth technique, notice that for every face we have two orange normals that need to get applied. This normal for these vertices, this normal for this vertex. So going back into here now, let's see. If we go inside of this if statement, we want to use edge normals, and we only use them if we do the smoothing. So mb smooth, and we need to call the same function, but we need to specify which normal to use. Now the one we want to use is corresponding to vertex 0. So here we need to use normal 0. Like so. And we're going to need to do the same thing down here in this if statement. But this time, instead of 0, we're using v plus 1. So up here, we're going to replace all the zeros with v plus 1. And then lastly, for these vertices down here, we also need to specify the normals. And this time we're using vertex v, so in here we're just replacing with normal v. And that's it. With those changes, we now should be able to have a cylinder that smooths on the screen. Let's go test it out. Back inside the class, inside scene initialize, let's see how we defined our cylinder here. Cylinder. Okay, we're going to create a cylinder with, let's say, 7 sides again. And let's build that. Oh, we got a problem here. No overloaded function takes 3 arguments. Oh, right. Our constructor, the default value here, should not be set inside the CPP file. Instead, it should be set inside the .h file. So we need to just make that little change. Now when we build, by default, it should be using the smoothing. So now the cylinder itself should look smooth. And there we go. Notice that the edges are now sort of blended together so that you can't really tell as easily where the edges of the sides are. However, when I'm jumping over top of this, you can still see that there are distinct edges. I'll make this cylinder smaller so I don't have to jump to demonstrate exactly what I mean. And let's increase the number of sides here to, I don't know, 9. And, well, for comparison's sake, let's make 2 cylinders. One with smoothing and one without. And I'll place them side by side so that we can see specifically what's going on here. Just make sure. Okay. Smoothing is by default turned on, so we want this second one to be off. So cylinder 2 will have the faceted edges, cylinder 1 will have the smoothed edges. Okay, and we'll also need a transform node down here. So we'll just copy the previous one we made. And this time, let's see, we'll put it back 6 and let's move it in minus 5 maybe? Or sorry, minus 0.5. That should put it pretty much flush against the other one that we have back there. And this one will be the second cylinder. Okay, let's give this a go. Okay, so there we go. You can notice the one on the left has faceted edges, the one on the right has smoothed edges. And notice how much smoother the one on the right looks. It's the exact same number of geometry, like it's exactly the same number of sides. However, because we've implemented the smoothing technique, the cylinder looks a lot smoother. Using this technique, you can actually get relatively good looking images of cylinders and things like that without having to introduce extra geometry. And this is what I was talking about earlier when I was referring to not having to go beyond 20 faces. Where's the geometry here? Okay, cylinder, this is 9-sided. So if we go up to 20 now for both of these, you'll notice that when we have a 20-sided smooth-faced cylinder, you can't really tell the difference between it and something that is really, really smooth. It looks pretty smooth to the human eye, so you don't have to worry about having to add more geometry now. Okay, so it was a relatively short video on how to implement the smoothing. Go around, play with it a little bit more, just to get familiar with how the normals work. Just be aware that before we're using normals for the faces, whereas now we're using normals for the edges. That's the only difference. Exactly the same geometry for both methods, smoothing or not smoothing. In the next video, I'll show you how to add texture coordinates to the cylinder, and once we add texture coordinates, we can then start applying textures to them, which will make these cylinders way more interesting. We can start creating things like barrels, we can create tires for cars, we can create pop cans for characters, we can do quite a few things with cylinders. They're quite useful. So come back for the next video to see how to implement the textures.